Computer Communications and Networks, Block 5, Unit 14, Fundamentals of Data Communication. In the Fundamentals of Data Communication, the main topics are communication model, data communications, data transmission, concepts, and terminology. The first topic is communication model. So the communication model in computer networking means where the sender channel sends a particular message over a particular channel or medium and the receiver gives the corresponding feedback of the sender's message. The sender side, the corresponding informations or encoded the particular message. In receiver side, that particular messages are converted into another format, that means decodes the message. So this is called as the communication model. So the next thing, what are the components involved in the successful implementation of the basic communication model, or as classified as 6 things. The first one is sender, the second one is encodes, third one channel or medium, fourth one decode, fifth one receiver, the sixth one is feedback. Sender means who sends the message is called as sender. Next, encodes. Encodes means it translates a particular messages into symbols like words, pictures, sound, etc. Channel or medium means it is used to transmit a particular messages. Some channels are face-to-face communication, the another one is over telephone communication, the third one is letter, television, newspapers, radio, everything is considered as a channel or medium. Next one, decode. Decode means a particular receiver decodes these symbols to understand what the sender wants to say. Next one, receiver. Receiver means a person who receives a particular message is called as receiver. The next one is for feedback. Feedback means after receiving a particular message, the receiver sends feedback to the sender, answer and what they understands from the message. So these are the 6 things are mainly involved in the basic communication model. Next thing, in the basic communication model, some maybe noises may happen, and sometimes noise is also part of the communication process and it disturbs the messages and it will be difficult for the receiver to understand the exact message that the sender wants to send. Next, a communication can be a verbal communication, written communication, or maybe a gesture. In the basic communication model, the sender encodes the message and transmits the message through communication channels like verbal. Verbal means face-to-face, over telephone, video calls, and a non-verbal. Non-verbal means newspaper, letters. So these 2 things are used for sending a particular messages to the receiver. Then the particular receiver receives the message and decodes it according to their understanding and again sends feedback to the sender. In the communication process, noise plays a important role of disruption. If noise is there in the communication process, then the receiver does not receive the exact messages. The next topic is data communications. In the data communication means it is for exchange of data between 2 devices via some form of communication medium. The 2 devices means one is called as a sender, the another one is receiver. Otherwise, it is also known called as a source or destination. In this data communication, the data is in the form of zeros and one. Next thing, data communication is considered as 2 categories. One is called as local communication, the another one is called as distance communication. Local communication means if the 2 communicating devices are in the same building or considered as a local communication. The second thing is remote communication. Remote communication means if the devices are located in the 2 very different places, that is called as maybe a distance locations. Next thing, the effectiveness of data communication system depends on the 3 fundamental characteristics. First one is delivery, second one is accuracy, third one is timeliness. The first one is delivery. The system must deliver data to the correct destination is known as delivery. Data must be received by the intended device or user. For example, if a sender A wants to send particular message to B, means B is a destination. So the exact message sent by A, it will be transmitted to the destination B. That is called as delivery. The second one is accuracy. The accuracy means the system must deliver data accurately. Data, that means the what the data sent by the sender, the exact information should be reached to the destination. Data that have been altered in the transmission and left means it may be uncorrected or unusable. The third thing is timeliness. The timeliness means the system must deliver data in a timely manner. Suppose the particular data are delivered late means it is considered as a useless. So these three things are used for identifying the effectiveness of data communication. The effectiveness characteristics are delivery, accuracy, and timeliness. So the next thing we are going to see about components of data communication. Here, in a data communication system, majorly 5 components are play an important role. The 5 components are, the first one is message, second one is sender, third one is receiver, fourth one is medium, fifth one is protocol. So this diagram shows the data communication system with the different components. In this diagram, first left hand side sender is available. The sender is connected by a medium. The next thing is right hand side, the receiver is located. The sender and the receiver both are used for, the sender is used for sending a messages. Receiver, they can receive the particular messages, as well as the sender and the receiver both are follow the some set of rules that is called as a protocol. The corresponding informations are transmitted through any particular medium. Next, what we will see one by one the 5 components. The first component is called as message. The message means it is the information. So what the information is to be communicated is called as message. It consists of text, numbers, pictures, sound or video, audio, whatever may be, or otherwise it is a combination of all those things. So these things are called as a message. The second component is sender. The sender means it is the device. That particular device sends the data message. The sender may be a computer, workstation, telephone, handset, video camera, and so on. Next, third one is receiver. The receiver also the device. In this category, sender and receiver both are a device. This receiver receives that particular message sent by the sender. It can the receiver also a computer, workstation, telephone, handset, video camera, and so on. The fourth component is medium. Medium means the transmission medium is the physical path. By this physical path, a message is traveled from sender to receiver. It can consist of the medium. Physical path can be consist of different category. Either it may be a twisted pair wires, coaxial cables, fiber optic cables, lasers, or video waves, etc. The fifth one is for protocol. It is a set of rules that govern or manage data communication. The protocols are used for agreement between the communicating devices. Suppose if any particular informations are transmitted without protocol means the two particular devices may be connected, but any informations are not communicating. So up to this data communication is over. So in this topic, we discussed data communication and the components of data communication. So the components mainly are 5 things. One is for sender, the second one is for receiver, third one is message, fourth one is medium, fifth one is protocol. The next topic is data transmission concept and terminology. Data transmission means it refers to the movement of data in the form of bits between 2 or more digital devices. Here bits are identified as zeros and one. This transfer of data takes place via some form of transmission media, for example, coaxial cable, fiber optics, etc. The next thing we are going to discuss about what is digital data transmission. The transmission of binary data across a link can be accomplished by either a parallel mode or serial mode. In parallel mode means multiple bits are sent with each clock pulse. In serial mode means only one bit is sent with the each clock pulse. There is only one way to send parallel data. There are two subclasses of used for sending a data in serial transmission. These two categories are identified as synchronous transmission. The another one is asynchronous transmission. In this diagram, it displays the data transmission is done in the two different category. One is parallel transmission. The another one is for serial transmission. There is only one way is followed for parallel transmission. Two different ways are used for serial transmission. One is called as synchronous. Another one is asynchronous. Now we will discuss one by one. The first one is parallel transmission. What is meant by parallel transmission means we are going to send n number of bits at a time instead of one. This is called as the parallel transmission. That means we are going to send any number of bits at a time. So that is called as the parallel transmission. Next, what are the mechanisms are used for parallel transmission means first we are going to use n wires to send n bits at one time. That way each bit has its own wire and all n bits of one group can be transmitted with each clock pulse from one devices to another. Suppose I am going to consider n equal to 8 means number of bits is 8 means I am going to use 8 wires are bundled in a single cable with a connector can be used at the both end. This is the example of parallel transmission. Left the sender and the receiver is available. The sender wants to send 8 bits of data at a time. So in this category, in parallel transmission, each bit can be transmitted on a single wire. So 8 bits are connected, combined into a single cable. So the 8 bits are sent together at the same time. The all 8 bits are sent, whatever sent by the sender, it can be received to the receiver. The receiver, for this process, it needs the 8 lines. What is the advantages of parallel transmission means the main thing is speed. Next, what is the disadvantages means cost, because we are going to transmit n number of data means according to that we need n number of wires. For example, I am going to transmit 100 bits means I need 100 number of wires are needed. So the cost is high. So that is considered as the one of the disadvantage. Next one is for it also limited to short distances only it is applicable. Suppose I want to transfer long distances means it doesn't support. It supports the parallel transmissions or support within the limited distance because we are using n number of cables. That is the major reason. The next thing we are going to see about what is meant by serial transmission. In serial transmission means one bit follows another. So we need only one communication channel. So what is the difference between parallel and serial means in parallel mode, all 8 any number of bits are transmitted at a single time. For example, I am going to use 8 bit means the all 8 bits are transmitted at a simultaneous manner. But in the serial communication, the all 8 bits are transmitted in a sequence manner. That means one by one. This is the example of serial transmission. The sender wants to send 8 inputs. The receiver also receives the same number of inputs sent by the sender. So in this case, all the 8 bits are sent one after another. Here we are going to use only one line. That means only one wire can be used. For this process, we are going to use two different things. The one is called as parallel serial converter. The another one is serial parallel converter. The parallel serial converter is used at the sender side. Serial parallel converter is used at the receiver side. So what's the purpose of parallel serial converter and a serial parallel converter means in sender side, the sender wants to send 8 bits. So the 8 bits are is in the form of parallel mode. So the all parallel 8 bits converted into one by one. So for that purpose, we are going to use here parallel to serial converter. That means all 8 bits are converted into single one by one bits. The same thing can be transmitted through the cable. After that, it will reaches to the destination side. Here also we are going to use serial parallel converter. So the main purpose of serial parallel converter is it received the serial number of inputs from the sender side. It will be converted into the parallel mode. Then only what the information are sent by the sender, the same format will be received by the receiver. Without the parallel serial converter or serial parallel converter, we can't able to transmit information in this serial transmission. So what is the advantages of serial transmission? Means it reduces the cost, because here we are going to use single line for any number of inputs. Next thing, communication within the devices is parallel. Conversion devices are required at the interface between the sender and the line, parallel to serial, and between the line and the receiver, that is called as serial to parallel. So next thing, this serial transmission is occurs in the two different ways. One is called as synchronous transmission, another one is for asynchronous transmission. The first thing, asynchronous transmission. Asynchronous means asynchronous at the byte level, but the bits are still synchronized, their durations are the same. The timing of a signal is very, very important. Instead of that, information is received and translated by agreed upon patterns. So the patterns are based on grouping a bit stream into bytes. Here each group usually consists of 8 bits, is sent along with the link as a unit. The sending system handles each group independently. It relaying it to the link whenever ready without regard to a timer. Without synchronization pulse, the receiver cannot use timing to predict when the next group arrives. The alert the receiver to the arrival of a new group, the extra bit is added to the beginning of the each byte. This bit is called this bit is 0. This is called as a start bit, to let the receiver know that where the byte is finished. One or more additional bits are appended to the end of the each byte. This bit is known as a stop bits that should be represented as 1. So the main things in asynchronous transmission, we are going to use two different bits. One is called as start bit, the another one is for stop bit. Start bit is represented as 0, stop bit is represented as 1. By this method, each byte is increased in size to at least 10 bits, because the original byte is represented as 8 bits. Apart from this, in each byte we are going to add 2 more bits, etc. One is called as a start bit, the another one is called as stop bit. So the total length of the byte size now it will be increased as a 2, that means 10. 8 are information and 2 or more are signals are used for receiver. In addition, the transmission of each byte may then be followed by a gap of varying duration. So the gap means it represented either by an idle channel or by a stream of additional stop bits. The start and stop bits and the gap alert to the receiver, it used for identifying the beginning and the end of the each byte. After that, and it allowed to the synchronize with the data stream. So this method is called as the asynchronous transmission. So what is the main advantages of asynchronous transmission? Means it is for two things. One is for cheap, the another one is for effective. So this diagram shows the example of asynchronous transmission. So the sender wants to send some particular data to the receiver. Here so many number of data are available. So in this first diagram I represent stop bit data and stop bit. So this is the direction of flow, left to right. So the sender wants to send the original data is for 11111011. So apart from this original byte, I am going to add the start bit and stop bit at the every message. So start bit is it is used to identify the receiver as it is the starting of the new byte. Stop bit is used for identifying where the first byte it stops. After that, the gap is used for identifying where the next data units are arrived. So these things are represented here in the diagram. So the next thing is synchronous transmission. In synchronous transmission, the bit stream is combined into longer frames which may be contained the multiple bytes are available. In this case, each byte is introduced onto the transmission link without a gap between it and the next one. Sender wants to send bits one after another without these start bits, stop bits or gaps. It is the main responsibility of the receiver. They can going to group the bits. The main difference between asynchronous transmission and synchronous transmission is, in asynchronous transmission we are going to add the start bit, stop bit and a gap. But in the synchronous transmission, the sender wants to introduce the all information in the without gap. After that, it will transmit it to the receiver also the same manner. The only responsibility of the receiver, they can going to group the bits. So this is the example of synchronous transmission. So the sender wants to send some set of group of bytes. The same group of bytes are transmitted from left to right. That means sender to receiver. The receiver only can responsible to split the data. That means bytes one after another. Here without the gap and start stop bits, there is no built-in mechanism to help the receiving device adjust its bit synchronization is midstream. Next one, timing becomes also very, very important. So the main advantages of synchronous transmission is speed. So the next topic is data communication terminologies. Data communication terminologies are listed at different categories. The first one is data channel, next one baud, third one bits per second BPS, fourth one bandwidth, fifth one DTR, that means data transfer rates. So the first one, data channel. So a channel means, it simply means a path. This path is used to carry or flow. Data channel means the flow of data or to carry the data from one devices to another. Simply we are going to set source to destination. The one device is called source, the another device is called destination. Who is going to send a particular message? That person is called as a sender. Who is going to receive that particular message? They are called as the receiver. In other words, we can say that the data channel is a computer path or medium. It is used to transfer the data from the sender to receiver. So the main path, data channel means it is the path. Using this path, the sender wants to send particular data to the receiver. So that is called as the data channel. The second category is baud. It is actually a common measurement unit of data transfer. So the baud rate means it measures the rate at which the data is transmitted from the sender to the receiver through in the data channel. Next thing, the baud can be expressed in the terms of BPS. BPS means bits per second. It simply determines the speed of the data transfer. So the third terminology is bits per second, that is called as BPS. It is a symbol of bits. It can be presented in the two forms, that is BPS, that means bits per second, and another one is for capital BPS, that means byte per second. It is also a measurement. It is used to identify unit of speed at which the data is transmitted. So bit rate means it is used to identify measurement of speed at which the data is transferred. The fourth one is for bandwidth. Bandwidth means it is the range of frequencies over a communication system works. It generally measures the amount of data that can be transferred in a given amount of time over a data channel. The next thing, it's the difference between the highest and the lowest frequencies of the data channel. The measurement unit of the frequency is cycles per second, that is it represents as the hertz. The fifth one is for DTR. DTR means data transfer rates. This one determines the rate of speed at which the data is transferred from the one point to the another point. Next thing, it is measured unit. Measured unit is bits per second, BPS, capital, that means bytes per second, or baud. So these three measurements are used to identify the DTR. In computer, data transfer is mainly measured in bytes per second. Data transfer between devices such as hard disk and CD-ROM is usually measured in millisecond. Thank you. In this unit, we discussed communication model, data communication, data transmission concepts and terminologies. Thank you.